Alright, guys. I'm going to check if we're all here. Let's see. Let's see what's going on with my live button here. Let's try question 8. It reads tx equals 3 sine 2x plus 2. Let's look to try to graph this. I see you, Navneet. I'm just waiting for more students to appear. Meanwhile, I'm going to go ahead and set up this little plane. Come on. That sucks a lot. Wait, let me see real fast. Let me see if I can just draw this with a math pen. Actually, oh yeah, they give me the coordinate plane right there. Right. Let's try to draw this with the good old math pen. So let me know you're here, guys, by shouting a hi. Let's try this again. All right, I'll go back to math pen. We're going to try y. No, yeah, that was equals 3 sine what's this one? Ugh. Hey, Amy, I think you're in the wrong class, Amy. The other class started at 10:30. It was from 10:30 to 11, and it finished. So let me try this one. This is going to be 3y equals. Oh, come on! So it's killing me. Y equals. Y equals. Don't let me draw on this thing. Okay, y equals 3 sine 2 2x. This is period 8, Navni, yes. This is period 8. This is period 8 and period 4. Ah. This. Let me do this one again. This one all over again. All right, so we're looking at problem 8, question 8, right? It's question 8. So we have 3 y equals 3 sine 2x plus 2. Want to graph that, which is what we're going to seek to do right here. That was question 8, Andrew. This is from the week sheet. You also see it in the classroom. It's question 8. It says graph tx equal 3 sine 2x plus 2 over the domain 0, 2 pi instead of axes below. I'm going to be able to graph this. Again, this is going to have an amplitude of 3, right? And this is going to be a sine curve. Now, in the time frame of 0 to 2 pi, I'm going to have 2 sine curves with an amplitude of 3. Right? So my graph should look in any regards. Let me just graph that. Yeah, I don't like you doing that for. I'm going to get this right, guys. Sorry I'm wasting a lot of your time on this. Okay. It doesn't like that. So I'm going to just graph it by hand. All right, so it's y equals 3 sine 2x, right, plus 2. I'm in a nice coordinate plane. Doesn't let me touch it, guys, per se. 1. This is going to be pi over 2 is going to be pi. Is going to be 3 pi over 2. Negative pi over 2 pi and 3 pi over 2. It essentially represents 270 degrees. No, Musawar. Period 2 you missed. It was at 10:30. This is for the period 4 and 8. So now I'm just going to seek to graph this, right? I should have drawn like amplitudes. Now this is going to be a sine curve. That's I essentially gonna need 2 from 0 to 2 pi, which is essentially negative pi to pi. I'm gonna have an amplitude of 3. So when I graph that, let me see, graphing in red here, and go up. Yeah, I'm gonna go right around here, go down right around here. Wait, that one. Go up right here. Oh, guys. I'm trying to avoid the lines because when this touches the lines, it has a tendency to mess things up. All right. That's one curve. Next curve. Destroyed it. Did you get what I'm saying, guys, right? Let me just take this over to Desmos. All right, so I'm going to go T of X equals, you guys could try this at home too with Desmos, 3 sine 2x plus 2. So this is essentially the sine curve, 2 sine curves from 0 to 2, from negative pi to pi, bumped up by 2. That's essentially how yours should look, guys. You just got to make sure that how you label your axes is pi half, which is 90 degrees. Then you have pi, which is 180 degrees. 3 pi over 2 is 270, and then 2 pi is 180. So it's essentially the sine curve, 2 sine curves from 0 to 2, negative pi to pi. Let's look at another question. I know I did 6 and 7 yesterday. This was question 8. Let's try question 9. Question 9 deals with the cosine curve, right? Same concept, except the cosine curve we know starts off not at 0, but generally at the amplitude. So in question 9 says, on the accompanying diagram, the accompanying set of axes, graph the equations y equals 4 cosine x and y equals 2. So you actually have 2 equations in the domain of negative pi to pi, which is essentially a 2 pi range, right? Express in terms of pi the interval for which 4 cosine x is greater than or equal to 2. Okay, that's pretty simple enough, right? So let's try to graph this. Again, I'll use Desmos for simplicity. We have y equals 4 cosine x. So when we look at this, right, and then we're going to also then graph y equals 2, right? So that's how the two things look like. If you notice, the cosine curve started with an amplitude of 4. And they want to know, expressed in terms of pi, the interval for which 4 cosine x, which is the graph, right, is greater than or equal to 2. This is x equals 2. So you want to know an interval from which is greater than or equal to 2. In terms of pi, right? So if you keep this in mind, this one right here, we're looking at the period. One period is 2 pi. So in this case, one period 2 pi would most likely stop at around, if this thing was drawn 100% accurately, it would stop at around 6. That's 2 pi. Right? So that's 2 pi. Now you want to know everything when this graph is greater than or equal to 2. So it's greater than or equal to 2 from what range? So if we're looking at this, right, it's 2 pi is going to be at 6. So that means at around in between the 2 and the 4, which is 3, that's going to be pi. So in terms of pi, well, what's everything greater than 2? You're going to say from pi to 2 pi, or pi to infinity. Let me know if you have any questions so far, guys. I want you guys to give 10 a try first. Go to Desmos, or you can actually graph it from your book. Remember, keep in mind of how I taught you how to label. Let me go try to go back there. I taught you guys how to label. Let me get rid of all this stuff right here. 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 If you're looking at how to label, right? We have a coordinate plane like that, and we have. This is from 0 to 2 pi. So this is going to be pi over 2. This is going to be pi. This is going to be 3 pi over 2. This is going to be 2 pi. Keep in mind that this represents 360. Come on. 360. This represents 270. This represents 180. This represents 90. And you have 0, of course. Let me know if you have any questions on this, guys. Keeping in mind that this is starting off at 2, 1, 2. You have a 2, so it's a 2 cosine, right, in the interval of negative pi to pi. So right here, it's going to be a negative pi over 2. Right here is going to be negative pi. Now, if we go negative pi to pi, so we're going 2 cosine, right? That's going to be within that interval. We're only going to get one. We're only going to get one cosine curves. That's going to start way up here. Right down somewhere in the middle. Go right up here like that. Oh, well, that was the curve. The curve looks something like this, guys. All right. Again, this thing isn't very cooperative with axes. Right? Some crazy stuff like that. Yeah, that was for 10. Yeah, Andrew, that was for 10. So it says on the same set of axes, reflect the graph drawn in part A in the x-axis. To reflect in the x-axis, you're going to have something kind of weird. Looks like that. Again, this should have dipped down, guys, so this is a little bit awkward. It's just whenever I do that, it messes this graph up, so... Yeah, any other questions, guys? Let me know. If not, then I'll end the session. All right, guys. So again, make sure you complete the assignment that I assigned. I actually put the worksheet on Google Classroom. Also, please make sure you complete the assignment on study.com. It's a big part of your grade. If you know a scheduler is being updated with that information, scheduler is actually showing the quiz, study.com quiz grade, and also show the worksheet grade. All right. If you have any questions, again, guys, leave the comments below, or also comment in the section on Google Classroom, or comment in the video afterwards. All right. This video should be recorded for anybody who missed it. All right. That's all, guys, and that's it. That's all for today.